Hi guys, today we are going to be doing Chapter 1, Section 2, The Nature of Science. We have three essential questions. They are, what are the characteristics of scientific inquiry? What are the differences between science and pseudoscience? What is scientific literacy and why is it important? Here's your vocabulary. If you have not yet completed it, please pause this video, grab your textbook, and complete the vocabulary activity. These words are going to be used, and it is important for you to have a general understanding of what they are before we begin. Our first essential question, what is science? Science is a body of knowledge based on the study of nature. The nature or essential characteristics of science is scientific inquiry. Scientific inquiry is both a creative process and a process rooted in unbiased observations and experimentation. So it is important to note that it is unbiased. All right? We are not going into an investigation looking for a certain outcome. Okay, we might have an idea of what might happen, but we're not hoping that it happens. We're going in with our eyes wide open, and we are open to any possible outcome. Okay, it is also a creative process in that the scientist has to design the experiment in a way that collects the most data efficiently and the most types of data. A theory is an explanation of a natural phenomenon supported by many observations and experiments over time. A lot of times in pop culture, we'll hear someone say, I have a theory, but they don't have a true scientific theory. In most cases, they simply have an idea that they think. They have a little bit of data to back it up, but they don't have a lot of data that is required to have a true scientific theory. Okay? A theory is different from a law. A scientific law describes relationships under certain conditions in nature, but it does not explain why that relationship is the way that it is. Theories do not become laws, and laws do not become theories. They are separate things, even though in pop culture they are usually used interchangeably. Science makes observations and draws conclusions. Scientists choose subjects to study, and they decide what types of data they are going to collect and how they're going to collect it. They then analyze that data and come to conclusions. Science also expands knowledge. Scientific explanations combine what is already known with evidence from additional observations and experiments. It's constantly building upon itself. Science is also driven by the search for new knowledge and constantly reevaluates what is already known. All right, think about back in the day when people thought that the earth was flat. Okay, somebody collected some data and said, hey guys, I don't think that this earth is flat. Like, this data actually says that it's not. And some other scientists were like, yeah, I've got some data that says the same thing. And they were constantly reevaluating what is already known. Pseudoscience imitates true science. The prefix pseudo means false or fake. So it is fake science. It's driven by cultural or commercial goals. Okay, it's usually trying to make money. And any new question or additional research that is done is generally not welcomed. It's generally, kind of hidden under the rug, shuffled under the rug, so that people don't know about it, so that they just buy into these claims that they're making, and they don't really question it. Okay, pseudoscience does not like it when people question it, because they don't have a good answer. Okay, it's not true science. Science challenges accepted theories. Scientists welcome debate about their ideas. Okay, they know that they don't have all the answers, and they're okay with that. They want to work together to gain the most knowledge possible. Science is advanced by accommodating new information as it is discovered. Scientists don't hide from new information. When something comes to light that they didn't know, they embrace it. They want to learn about it and see how it connects with what we already know. Science questions results. In science, observations or data that are not consistent with current scientific understanding are of interest. These inconsistencies often lead to further investigations. In pseudoscience, those inconsistencies are disregarded or ignored. They're just kind of swept under the rug. They're not really talked about. They don't do any more investigation to understand why it's happening that way. In science, a rather popular example of this is the relationship between bats and birds. For a long time, it was thought that birds and bats were closely related because they both fly, they both have wings, and they look kind of similar. But when scientists started looking at the structures of the bones inside the wings of birds and bats, they discovered that they don't look very similar. But whenever they combined the structure, or compared the structures of a bat's wing to those of a human arm, they noticed that a lot of the bones are rather similar. Okay, they may have elongated in certain areas to enable the bat to fly better, but the bones still look very similar. All right, and that led to further investigations and more investigations, and as we develop more, we have more investigations and over and over and over again. Science also tests claims. Scientists use standard experimental procedures when they are doing an experiment because they are steps that lead to the least mistakes. All right, they are the most efficient and best ways of doing something. They then take their claims and they base them on a large amount of data and observations obtained from unbiased investigations and carefully controlled experiments. Our keys here are unbiased investigations. They're not picking and choosing what data they accept. They're going into it with their eyes wide open, and they are accepting whatever outcome is come to. They're also carefully controlled. Okay, they make sure that there are no outside influences affecting their data. Pseudoscience makes claims that cannot be tested. Okay, just by the nature of what they're claiming, they can't do a true scientific study. All right, they are also usually a mixture of fact and opinion. Okay, in science, we don't have opinions. Okay, opinions don't really matter in the scientific community. Okay, science relies on facts and things that can be tested and observed. Science also undergoes peer review. Before it is made public, science-based information is reviewed by other scientists. Peer review is a process by which the procedures used during an experiment and the results are evaluated by other scientists who are in the same field or who are conducting similar research. A lot of times, another scientist will conduct the experiment again to compare their results, compare their observations to the initial ones. If they get the same results, fantastic. If they don't, they'll contact the scientist and say, hey, I didn't quite get what you got. Let's figure out what's going on there. All right, it is important to be scientifically literate. Okay, science literacy is when a person who is scientifically literate combines a basic understanding of science and its processes with reasoning and thinking skills. All right, it's when you understand the process of science, how it works, the steps, the procedures, and you apply that to things that you are seeing in the world around you. Okay, it's important nowadays to be scientifically literate because there are lots of commercially produced products out there that are making claims that they will boost your memory or support your metabolism. This pill will make you burn 60 pounds in a month. Those are usually pseudoscience. They are making claims that cannot be supported. Ethics is a set of moral principles or values. It's important for scientists to have ethics because they set the parameters, they set the boundaries of what scientists can and cannot do. So a review, our essential questions are, what are the characteristics of scientific inquiry? What are the differences between science and pseudoscience? And what is scientific literacy and why is it important? If you cannot answer any of these questions, please go back and rewatch the video. If you still have questions after that, we will discuss them in class tomorrow. Once again, at the bottom of the screen are your vocabulary terms. Please make sure that that is finished before class tomorrow.